Hey, welcome to Build&AI. I'm Nia, your AI learning guide. Let's get into it.
Welcome to this explainer. Today, we're diving straight in to demystify React, and we're going to explore exactly how its modern ecosystem has fundamentally changed web development. Whether you're trying to figure out why everyone suddenly moved away from vanilla JavaScript, or you're just looking to refine your grasp on modern front-end architectures, you are definitely in the right place. We're going to break down the core mechanics of React, why it's so incredibly fast, and how tools like Vite and TypeScript have completely standardized how we build for the web today. Let's get into it. Here's a quick look at our roadmap. 1. Why React rules the web. 2. Declarative versus imperative code. 3. The virtual DOM engine. 4. Anatomy of React components. 5. Modern setup with Vite. And finally, 6. JSX syntax and data flow.
All right, Section 1, Why React Rules the Web, and the big paradigm shift of 2013.
To really understand React, you've got to cast your mind back to 2013. Launched by Facebook, React arrived at the exact moment web apps were just getting overwhelmingly complex. Think about an app like Facebook back then, right? You had notification counters updating in real time, news feeds loading as you scroll, buttons changing colors, messages marking themselves as read. Doing all of that manually meant your code quickly turned into this unmaintainable, tangled web of event listeners and direct DOM manipulations. React was built to handle literally billions of daily interactions by completely rethinking how we update the screen.
Now, the crucial point here is that React isn't a full framework. It's actually a highly specialized view layer library that just quickly became the industry standard. It completely popularized component-first thinking, which allows us to build really complex UIs from simple, reusable pieces. It also brought in the virtual DOM to keep things lightning fast, which we'll look at in a minute. And today, because of its massive ecosystem and the sheer volume of React code out there, it has exceptional AI support. Seriously, if you ask an AI coding assistant to generate a React component, you're going to get fantastic idiomatic code right out of the gate.
Moving on to Section 2, Declarative versus Imperative Code. This is a whole new way to think about UI.
The best way to think about declarative programming is like ordering a meal off a menu. You simply tell the waiter, hey, I want a burger and fries, and boom, it arrives. That's declarative. The old imperative way, using vanilla JavaScript, was like micromanaging the chef step by step in the kitchen. Take out the beef, form a patty, turn on the grill, flip it after 3 minutes. It's exhausting and it's super prone to errors. React lets you skip all that and just describe the final state you actually want.
And this brilliantly illustrates why React scales so beautifully. If you're using vanilla.js to make a simple like button, you have to manually create the element, attach a listener, increment a variable, explicitly change the text, check the count to change the color, and then check it again to disable it. Managing 100 interacting components like that is an absolute nightmare. But declaratively, with React, you just return a button whose color and disabled state are mathematically tied to a single likes variable. That's it. React handles all the heavy lifting.
Let's hit Section 3, the virtual DOM engine. This is React's real performance secret.
We have to ask this question first. Why is updating the real DOM so incredibly slow? Well, the document object model is the browser's in-memory representation of your page. Every single time you touch it, the browser has to recalculate CSS styles, compute layouts, and trigger these really expensive full-page reflows. Updating one element? Sure, that's fine, but updating 100 elements individually? That's going to bring your performance to a crawl.
So React solves this with a surgical strike and introduces this clever intermediate layer, a lightweight JavaScript replica of the DOM. When a state changes, React updates this virtual DOM first, which happens in a flash. Then it uses a process called diffing to compare the new virtual tree against the old one. Once it calculates the exact differences, it collapses them down and applies only the absolute minimum necessary patch to the real DOM. So 100 logical updates might result in just, say, 5 actual DOM operations. It's brilliant.
And this brings us to a super important React rule, why it absolutely demands unique keys for list items. It's all about keeping that diffing algorithm we just talked about lightning fast. If you add an item to the top of a list without unique keys, React gets confused. It thinks every single item in that list has changed its content, so it needlessly re-renders all of them. But when you use keys, React instantly recognizes, oh, hey, this is just one new item at the top, and it efficiently just pushes the existing unchanged items down.
All right, Section 4, Anatomy of React Components, the literal building blocks of the web. At the end of the day, Every component in React is essentially just a JavaScript function that returns a description of some UI. But it relies on two fundamental concepts to manage data: props and state. Props are your external configurations. Think of them as arguments passed down from a parent component, like telling a button what its label should say. State, on the other hand, is the component's internal memory. It's what lets a component track changes over time during user interaction, like remembering how many times that specific button was clicked.
As you're building out your project, you'll naturally fall into creating about 5 main types of components. You've got presentational components, which are just for pure display. Functional components. These act as the brain, holding your state and logic. Wrappers are containers that add themes or data contexts. Layout components to structure the page. And compound components that combine related elements, like a modal window. Splitting your UI up like this is absolutely crucial. It prevents that massive anti-pattern of mixing your raw data fetching logic directly with your visual markup, which otherwise makes your code practically impossible to reuse.
Section 5. Modern Setup with Vite. It's time to leave Create React App behind. For years, the absolute gold standard was a tool called Create React App. But let's be honest, as projects grew, it became painfully slow. Enter Vite, which literally means fast in French. Vite has completely replaced Create React App as the modern standard. Why? Because instead of bundling your entire massive application before the dev server can even start, Vite utilizes native browser ES modules. This means your dev server starts up in literal milliseconds, no matter how big your project gets. Plus, the configuration isn't hidden behind frustrating magic scripts anymore. It just lives in a simple, plain text file.
Finally, Section 6, JSX syntax and data flow. This is where HTML meets JavaScript. While JSX looks exactly like HTML, remember, it is fundamentally JavaScript under the hood. Because of this, you gotta tweak some of your old HTML habits. For instance, you can't use the word class for CSS classes anymore, because class is a reserved keyword in JS. So we use class name instead. Event listeners like onClick, those have to be camel case to onClick. Inline styles can't just be raw strings, they need to be passed in as actual JavaScript objects. And this is a big one, every single tag must be explicitly closed, even things like inputs and images.
Now, watch out for this one. It's the classic zero and anything bug. A lot of developers try to render a list conditionally by writing count and component/component. Makes sense, right? But if that count happens to be 0, the whole logical AND expression evaluates to 0. And because React actually renders numbers as text on the screen, it will literally print a stray 0 right onto your beautiful UI. Definitely not what you wanted. The fix is super simple though. Just always compare explicitly, right? Count greater than 0 and anything.
As your app grows, you're going to naturally compose these components together like building blocks. You start down at the bottom with level 1 primitives, small single-purpose things like buttons and inputs. Then you snap them together into level 2 compounds, like taking an input and a button to make a search bar. Finally, you combine those into level 3 pages and layouts to form your complete working application.
But here's the catch, and it's a strict rule of React data flow. Sibling components cannot communicate directly. If your search bar needs to talk to your search results, they can't just whisper to each other. You have to do what's called lifting the state up to their common parent component. That parent holds the shared state and then passes it strictly downwards to the children as props. In React, data only ever flows downwards.
To keep track of all this, tools like React DevTools are basically a superpower. They let you inspect this data flow live right in your browser, completely bypassing the need to scatter console logs everywhere. So, armed with the virtual DOM, component architecture, and the raw speed of Vite, you've got the theory down. But here is the real question to leave you with. As web applications inevitably begin to integrate AI natively on the client side, how will you use these declarative building blocks to design the interfaces of tomorrow? Thanks so much for joining me on this explainer, and happy coding.
And that's a wrap for today. If this lesson was helpful, go ahead and hit that subscribe button so you never miss a new episode. We drop 3 new lessons every single week, all designed to help you learn, build, and launch with AI. Share this with someone who's on the same journey, and I will see you in the next one.